Hi, my name is Jason Odoom, and I'm a DevSecOps engineer at Clarity Innovations. Welcome to my talk, Jenkins Can Do It All. So I'll try as hard as possible to not invoke the K word. When I say the K word, it might get a little too much, but when I say the K word, I'm sure you'll understand what I'm talking about. I'll try not to use that word as much as possible in my presentation. So one of the big motivations for giving this talk was the current space that we're in, in regards to uh, container orchestration platforms and their popularity, and of course that one big popular platform, the K word, and whether or not you need it, whether or not you need to use it. I'm sure there are a lot of small to medium-sized businesses that are using these platforms, and they most likely don't need to use them. Not because it's bad, but because they're just not ready. It's not whether they're running a microservice or a monolithic application. That's completely irrelevant when it comes to whether or not you're ready to run container orchestration platform. But what really matters is scalability. Do you really need to scale? How many users do you need to support? How many users do you have? And that's one of the big questions to ask when you're looking to decide if you can or if you should start using a container orchestration platform. But one of my favorite tools is Jenkins, which is a CI/CD automation server, and it's quite powerful. It can do a lot, and it has a very rich plugin system, which provides it more features and makes it extensible, as well as the built-in internal features. Uh, for example, the different pipelines, declarative pipelines, and just the amount of things that you can do by just using it. So let's get started. So there are a couple problems, as I hinted at in the previous slide in the beginning. The first one is popular container orchestration platforms are ignited FOMO in industry, and FOMO is fear of missing out. So that's the fear of missing out. That's when you see everyone doing something that you wish you could do. You kind of feel like you're left out, and you want to be a part of that. You want to be a part of that greatness. You want to be a part of that next big thing. And that's a serious problem because your peers may be doing it, but you have to understand maybe your peers are corporations and you're just a business and you're still learning, you're still growing, and you probably don't need to scale now. You probably don't need this. And you don't need this. And there are alternatives that you should definitely research before uh, considering diving into something as big as a container orchestration platform, because it can get costly if you don't do the necessary research. The second point is using and managing container orchestration platforms when you don't need to scale is wasteful and costly. It gets expensive. Besides hiring engineers that are gonna have to not only learn this but manage it, as well as the different features that come with platforms such as these. You may think you know what this platform is capable of, but it has so much to offer that you might be overwhelmed. So it's really important to be prepared and understand what you're getting yourself into. And the third bullet point is using platforms for platform's sake as necessary. Just because it's there doesn't mean you have to use it. It's not for everyone. Don't use it just because it's there. It's there to help not only drive innovation, but help fix your issues, to help fix your problems. And if you don't have these big problems, like some corporations do, it's not worth using. Sure, it's okay to learn it in your free time and understand what it does, and maybe prepare yourself for the future. But at the moment, especially if you're a small business, and if you don't need this, then you shouldn't use it. And that leads me to the last point: lack of research into alternatives before implementing the latest and greatest. You have to do your research before you decide to implement a new technology in your company or organization. If you don't know anything about it, just what's out there in industry and in regards to popularity and how everyone's using it, that's not good enough. That's not going to help you and your company grow. Don't don't follow popularity. because everyone's using it. You have to understand the technology first, and then you have to, most importantly, discover if that piece of technology will help you solve problems in your organization. So why Jenkins? Jenkins is, in my opinion, very simple. It's really uncomplicated to configure, very extensible via plugins and other built-in features. It has sufficient security features to allow different users to have access and limit their access. It's also cloud agnostic, meaning you can use AWS, GCP, or Azure to integrate. So no trade-offs. Jenkins is scalable, it supports containers, it supports automation. It is a CI/CD automation server after all. It's definitely metrics capable, and it's very configurable. So what does this mean? So Jenkins, if Jenkins is missing a feature that your organization needs, you can always look for a plugin. There are so many plugins available to provide uh, more additional features to Jenkins. So how do you determine if Jenkins is right for you? So let's take what I said previously in regards to when to determine not to use the keyword or a container orchestration platform. So if you know the keyword isn't right for you, maybe Jenkins is right for you. Do you need high availability? So in terms of scalability, supporting many different users and having to be always available uh, globally, especially, is this important to you and your company? Do you need to provide this feature now? If not, then you can cross this first bullet point off. Do you need to manage a large amount of containers? If you don't need to manage a bunch of containers or even deploy a bunch of containers, then you probably don't need to use the keyword, and Jenkins is most likely your best choice. And also, can you afford to manage it? So if you can't, if you don't need to manage, or if you need to manage a bunch of containers, will it cost you? This is also a really important factor to consider. Also, the last one, does your app consist of multiple services? This goes back to the first point that I made in the beginning regarding if your application is monolithic or a microservice, which is irrelevant in regards to whether or not you should use the keyword. But if you're using different microservices and you're deploying them at scale, then also consider this. All right, let's dive into Jenkins. So as I mentioned before, Jenkins is a CI/CD automation server. It allows you to deploy apps to different environments, as well as test them before deployments. It's open source and written in Java, and it supports many plugins. Let's get started. In this example, we'll look at the declarative pipeline. So in the declarative pipeline, we basically have this syntax, pipeline, and we define our node being the server that we build our application on, as well as instructions for deployment. Later on in this presentation, we'll take a look at Ansible Tower and how it integrates into Jenkins and how you can use Ansible to actually support some really cool features. We also then have the scripted pipeline, which provides you more freedom, because in the scripted pipeline, you can create you can provide more instruction compared to the declarative pipeline. In a scripted pipeline, by the way, is based on Groovy, as is the declarative, but now you're able to code and actually define what you want to do and it doesn't get in the way. Whereas declarative, you're given sort of a bunch of syntax that you have to use, and you have very little room to sort of innovate or define what you need to do with your application or in your environment. And scripted provides that freedom. So do you have to do this for all pipelines? And what is this? Do you have to define each file, each declarative pipeline or scripted pipeline in your Jenkins file for every single stage in your environment? And the answer is no. Suppose we create a file, a scripted pipeline. By the way, it's important to note that this code here, whether it be scripted or declarative, would be in a file called Jenkins file, which Jenkins would parse through and run. But if we have different environments, we don't have to write multiple Jenkins files. We can rely on maybe 2 Jenkins files or 2 to 4 Jenkins files at max, and apply them to different environments or teams within our organization. And the way we do this is via shared libraries. So here is an example for scripted and declarative. So in the scripted library, we see here that we're importing our shared library. Our shared library is at this location or this directory, and we're using it in our development stage. And we're basically importing code that can be used in our Jenkins file. And this is how it will look if you were to write this declaratively. And it's similar. So this allows us to reuse code without having to rewrite it multiple times. So we don't have to repeat ourselves, which is a very important. Okay, so unleashing the power of Jenkins, I should say. So one of my favorite automation tools is Ansible. Ansible, like Jenkins, is open source. It enables infrastructure as code, and it uses YAML. So by writing YAML configuration files, you can provide it to Ansible to execute. And Jenkins has actually 2 Ansible plugins, one being Ansible Tower, which is a user interface for Ansible that allows people in your organization to create and run playbooks, and you can provide them the appropriate permission. Think of it as a more friendly way for others to be able to interact with Ansible, as opposed to just using the command line or giving them access to a server on a system to run playbooks or develop Ansible playbooks. So before I move on to this next section, let's take a look at the Jenkins file. So in this Jenkins file, we have our declarative pipeline. And I really want to combine Ansible and Jenkins at this point of the presentation. So we're using Ansible and Jenkins together, specifically Ansible Tower, where we define different job templates for each environment. Like we have a dev job template for our dev environment, a test job template for our test environment, and a staging job template for our staging environment. And in this example, we're using the Jenkins Choice plugin. So when you go to Jenkins, there's a GUI in your pipeline that allows you, that provides a drop down to choose which environment to deploy to. So in this example, we have a node labeled cloud node. It could be labeled anything per the configuration of your Jenkins server. And we have a notification stage, basically lets you know that the build has begun and it started, and it'll send an email to whoever is in the email list of your organization if you wish. And then we begin to deploy or deliver the artifact for deployment. And then we do the same thing for the testing stage and the staging stage. And also another option being deliver via tag if the artifact is tagged with a number. And then at the end, we send an email with a status. If it fails, then I'll send an email saying it failed. If it passed, then I'll send the email saying it passed. When the internal IP is equal to the one that we've defined or specified because we already know what the IP should be, then we set the we set the environment to the appropriate uh, node name or fact. So once we've done that, once we've established the facts, then we remove our old artifacts. Our old artifacts being the one we previously deployed, and I've just realized that I'm going ahead and showing the atomic deployment configuration. So really quickly, let me switch back. Okay, so let's take a look at this configuration. In this configuration, this is an example of an Ansible playbook. In this Ansible playbook, we are defining facts or variables for each environment. So in the first example, we're setting a fact for the dev server. If the dev server has this IP address, if the IP address is equal to 10.1.1.1, then we know that it's the development environment. And we're using the Ansible default IP command to set or grab the internal IP address. And of course, that's how we set the condition for each environment in this playbook. So we know we're on the testing server or the staging server because when we use the Ansible, when we use the Ansible default IPv4 command and we compare it to the internal IP or the IP that we specified here, if the condition is true, then it's going to set the environment appropriately. Next, we're going to import dependency task. So this would be another playbook, an external playbook in a separate directory that's going to do some additional things for us. Maybe we don't want to have like such a long file, such a long playbook, so we want to import separately, for example. And once we've done that, then we move on and we download, our artifact being our application. So in this case, we're downloading the artifact from Nexus, and it's going to download to our temp directory. And then it's going to clean the web root where the application is being served, for example, for our www HTML. And once it's cleaned the web root, we won't be serving our application. Our application will actually be offline. If a user tries to access it, they'll most likely get a 500 error. And then once you clean the web root, we're going to unarchive or extract our artifact to the web root, that being for our www.html. Web root here in the playbook is defined, and this variable is defined outside of this playbook globally in our Ansible directory, in our playbook directory. And once we've done that, then we build the application, we compile the application. As I mentioned, to these node packages to be installed for our app. Once we've done that, we add necessary configuration files. We add our database configuration.json template. This template ending in .j2 for Jinja, which allows us to interpolate different variables within our configuration file. So the way variables work in Ansible is by these curly braces. And in regards to template, and we'd have this file that ends in .j2, and you'd see syntax similar to this that allows us to replace different parts of it with actual predefined variables in our configuration. And then once we're done with that, we add another template, the environment template. And we add more templates for each environment. If we're on staging, then it'll add staging's own template. If we're on testing, it'll do the same thing for testing, if we define it, of course. And then replace the environment with appropriate server IP. This being maybe, our application requires that a server IP is hard-coded. So we grab that via a variable server IP, which we define above in this in the facts, in the Ansible facts, before we actually begin creating the instructions or the tasks, we define the facts for each environment. So that's why it's important that we set this up before we make use of them later on. And now, once we've done that, once we've replaced the necessary variables and we've built our app, next we're going to apply the appropriate server permissions. In this case, we're using Apache web server. We'll apply the appropriate and safest web server permissions. And then we're going to start the app. And in this example, we have storefront being where we're serving our homepage, our index.html. And we're going to start that up, and that's it. Then we reload Apache, and now it's accessible to our users, and we're done. And this is cool, but the only major problem is we took the site offline. So when we deployed via Jenkins, we deployed our app via Jenkins. Jenkins, of course, used the Ansible plugin to make this happen. In our Jenkins file, we defined, the Ansible job template to use, as I briefly showed you here. So Jenkins knew which templates to use, which playbook to run. But and of course this is per environment, but one of the biggest issues in regards to this is that while we deployed, we took our website offline. So now no one was able to access it. If a user wanted to send us a message or buy a product, they wouldn't be able to until our site finished deploying. And who knows how long that took. Of course, Jenkins stores metrics in regards to how long a build takes, and we could use that to help decrease build times if we prefer, but not at the cost, hopefully, of taking our site offline where users can't actually do anything. And that's where atomic deployments come in. App availability with atomic deployments. So atomic deployments are really cool. Basically, they use symlinks. So in this previous example where we just took our site offline to the redeploy a new one, atomic deployments make it possible so we can continue serving a live website while deploying our updated or new website to the same host. And once deployment has finished, we switch the symlinks and serve the newly deployed application. So we avoid downtime by keeping the servers online while we're deploying. Of course, this allows for pipeline expansion. We can do a lot with this. You shouldn't necessarily think about this as creating things from scratch, but this is one of those things where we have the freedom to do whatever we want because Jenkins allows us to through its configuration, through the different plugins that it has available, and of course through Ansible and its many features and ease of use, in my opinion. So this also allows us, by the way, to roll back easily. So in the case of downloading artifacts from Nexus, for example, depending on how long we choose to store artifacts in Nexus, we can later on configure a similar pipeline. Let's call it a rollback pipeline, for example, and roll back previously deployed artifacts if something doesn't go well. But also, here's another important thing to consider. If we're deploying an application via atomic deployments, where our site is online, it's continuing, it's serving, it's easily accessible to users. We've just deployed a new one. No one knows what's going on in the back, obviously, except for the engineers. Users have no idea what's going on because they can still access the website. And let's say that deployment that's in progress somehow breaks, something goes wrong. It makes its way from dev to testing, all right, and makes it to station, okay, and then it gets to production and something happens. Who knows? Who knows why? But something happens during deployment to production, and the app fails. The cool thing is this buys us time because through the Ansible playbook, we define in our and I'm skipping ahead really quickly, but we define this condition here that says when. So we're using this when condition available to us via Ansible. So if our deployment failed or something failed, a file is missing, it won't it won't complete, it won't continue. And this can be up to us. Maybe the symlink doesn't switch, right? Uh, and then we deploy again and it starts over. Because at that point, we haven't switched to the new deployed application. We're actually serving a copy of the previously deployed application. Because what happens is every time we've deployed, we mirror the current deployment to a separate directory that gets switched to during deployment. So this way, we have every past deployment for us to serve to the user, and then we can wipe out a copy of that and then build the current deployment or the current or new application, and then switch symlinks again to serve to our users. So in this configuration, this playbook, this is the atomic deployment. We do the same thing that we do in the previous playbook that does not support atomic deployments. That takes our website offline. But the changes that we make here are crucial to actually keeping our site online. The first being we remove our current release symbolic link. So these directories are created beforehand. For example, var www.html is usually the directory where you would serve web content. In this case, we'd have, for example, var www.html release and var www.html previous release. And then once we download the artifact, we would switch the symbolic link to, in this example, previous release. So we're serving previous release, and it's very quick. It's at the blink of an eye. No one barely notices anything. And of course, the previous release at this point is it's just current release. It's a mirror of current release that was copied over, cloned at the end of the previous deployment. And once we've done that, we start our app again because it's a different instance. It's being served from a different location, different to the one that was being served previously before we switched the symlinks. So in order to avoid any issues, we start a new instance, and we're using Process Manager 2 to handle that in this case. Once we've done that, we remove our deploy cache. We clear it completely. And deploy cache being where we extract the contents of the archive that we downloaded from Nexus. And deploy cache isn't meant to be persistent. It's just meant to it's just a place for our app to sort of temporarily live while we provision it. And once it's good, once it's successful, we ship it out or copy it to a different part of the web server to be served later. And then we remove deploy cache and then we recreate it to avoid any permission or issues relating to having old remnants of past deployments, just to be on the safe side. And once we've done that, then we extract the contents and we begin to provision our application. So depending on the type of application, you'll know what Ansible modules to use or how to provision the application. And here become true, privilege escalation part. But anything that we do as root, of course, we take care of at the end by setting the appropriate permissions. And we do this for a couple of reasons. One being to make sure everything runs well. There are no issues during provisioning. Of course, you don't have to if you don't want to, but depending on the application and the modules that are being installed, it may be necessary. And in this example, in regards to npm module, if you like to do that, there's certain features that you have to set. For example, on say perm equals true or is true. And once we've done that, we do a check here. This is actually what I was referring to before, where we check if the build has the deployment has passed. And this is just a simple one. It can be really complex depending on what you prefer. But in this example, we check to see the index.html, which is of course the home page for the app. In this case, the microservice storefront. We check if it exists. If it doesn't exist, then the user won't see anything once it's deployed. and we won't allow for that. So we check to see if it exists. If it is, then we store that. Sorry, not if it is, but if once we do the check, we store the value in a variable. So we check to see if this index.html file exists, because this is our home page. So if it exists, then not necessarily if it exists. So once we do this check, we assign this check the value or the outcome of this stat using the Ansible stat module to this variable storefront underscore index, and we have a condition. So when the file, or if the file doesn't exist based on the condition, then we're going to end the play. We're going to fail this whole deployment, and we're not going to continue. This is a nice way to save time, or rather give us time to see how this happened, to investigate before we redeploy. And this is actually the part, if the configuration is not right, this is actually the part where things can get a little bad. So in the case, as you remember in the beginning, what we did was we switched the sending to the previous release, and that's the one that we're serving now. So if we did the same thing for our new deployment, and once we've done that, once we remove the current release directory, then we recreate it, and then we just go through and set the appropriate web server permissions. We copy our deploy cache directory to the current release directory, because it's sort of passed. It was built appropriately, and now we can continue the process. We can provision the app and get it ready. Move it to this directory, then get it ready to be served once the deployment is done. We add our appropriate configuration files, remove any process IDs from the previous release directory that's being currently served, and we stop all our services. And then here's the part where we change the symlink and we serve the current release of the application. And then we apply the appropriate web server permissions. You can never be too careful. And then we restart our application, and then remove the previous release directory in preparation for the cloning, where we'll clone our current release directory. We'll copy the contents over the previous release directory, which will prepare us for the next deployment, where that will be served, so we can make way for the new version. So now that I've explained some of the configuration for the atomic deployment, we can move on. All right, so yes, atomic deployments make version rollbacks easy. And that's one of the features that it provides, besides uptime, besides keeping your application alive and accessible to users. Thank you for coming to my CDCon talk. If you have any questions, I'll be happy to answer them. Thanks.